Some of you came back. That's awesome. This session's not going to be as heady, all right? This session's going to be more about how do we read those landscapes? What are plant indicators telling us? What's this whole world that can open up once we start to get our diagnostic heads on, right? Whee! So just to summarize what we were covering before, if we really want to look at how do we lift plant biological signals, optimizing photosynthesis is the first place to start. What's going on? What's putting a drag on that system? Is it roots? Is it something like boron? Is it inadequate calcium or phosphorus? Get interested in why are my plants not photosynthesizing very well. Getting diversity into the system. That might be diversity of animals, diversity of microbiology, diversity of plants. Diverse foods for microbes, trampling material. Imagine you're massaging that land back to life. Seed dressings, I think, are a big one. And just start thinking, there's more underground livestock on your property than there is livestock above the ground. And you need to manage them, because when you manage them, then now they can do the work for you, and you can sleep, go on vacation, do all those fun things, and let the microbes do the work. So if your underground workforce isn't nurtured, you're going to have to pay for those services. And I said good things before. It's fine. You get the gist. Okay, so what is a weed? A weed by any other name would smell as sweet. How do you define a weed? Plant in the wrong place. Says who? Whose wrong place?
It's the most healthy plants we have in the garden.
It's probably. Yeah, it generally is. But I think that the point is a weed is a subjective terminology for an indicator plant based on your opinion, right? Will cattle eat black grass? Yeah, so not a weed for cows, right? So a weed for croppers. So starting to look at, okay, a weed is very subjective. It's all about your opinion. So in a square foot of soil, there could be thousands of weed seed. They did a study in New Zealand actually looking at just a square meter of soil. And in that meter of soil, they found about 2 kilos of clover seed, about that, with no clover growing, right? What is that seed bank? What's sitting under there? Don't worry about your neighbors throwing thistle seed over the fence. Don't worry about what they're doing. What germinates is dependent on the signal that they're receiving on your property. So I want you to start to ask this question. What are you trying to tell me? I think Andrew this morning mentioned a book called When Weeds Talk by Jay McCaman. I do recommend it. It is an American book, so you've got to put it into English, but welcome to my world. When Weeds Talk. And it breaks down weeds in terms of their nutritional makeup. What are those soils high in? What are the soils low in that might lead to this particular weed? But I want you to ask the question of, is it because ground has been bare? So we have certain plants that will cover bare soil. Nature abhors a vacuum. What are those weeds that you might see in bare soil? Thistles? Yeah. Sorry, which one? Plantain. Chickweed, nettles, oxalis. So think scrambling weeds as well. So wandering, lily, purslane, really good. So anytime we're going to have bare ground, that sends a signal. Some of those signals might be due to bare ground. It might be that you get a buildup of nitrates when soil is bare and we get the nitrate weeds. Nitrate weeds include your thistles, your nettles, your nightshades, your foxtail barley. They are nitrate indicators. That might be because the soil has been bare, because you're applying nitrogen, because your management is insufficient to convert the nitrogen forms. All right, we're going to talk about that. It might be that you have low organic matter. So there's some plants that will germinate because of low organic matter. That might also be bare soil. Low organic matter might not be your problem. It might be because you have an imbalance of minerals. So if we see an excess of potassium, and you might see this where animals have been camping underneath trees and you get a ring of thistles or nettles, that's telling you there's an imbalance. It might be nitrates, it might be potassium. You see these plants when microbial activity is undermined in some way in forest ecosystems, and we see those kinds of plants. They are not natural companion plants to trees. They're telling you there's a mineral imbalance due to some kind of dysfunction, right? Is it due to a microbial imbalance? We have what we call the weeds of disturbance, right? So early succession or very high bacterial plants, what might they be? Doc. Nettles, reeds, and rushes. Pretty much most of the headaches in cropping, those cropping weeds are bacterially dominated soils. We also have our fungal dominated weeds. Mullein, foxglove, woody weeds, briars. They're telling you there's a mineral imbalance. Maybe you want to grow briars. Maybe you're trying to do it in a woodland, and then that's fine if we start to see mullein. You have mullein, right? Not that, what do you call it? Mullein then. All right, thank you. Learn something new every day. I've probably been saying it wrong my whole life. Fine. Okay, so there are weeds that could be indicating, and these things, again, could be all interrelated. They might be a safety valve for toxins. The first time I saw this actually was was on a sheep and beef farm, and they had a gully, just one gully that was full of milk thistle. And I said to them, what's underneath the ground there? And he's like, oh, it's just an old landfill, and we dumped a bunch of batteries. I'm like, thank you for your honesty. And then after, I was working in the San Andreas fault line. And in that San Andreas fault line in California, all along the fault line, you see milk thistle. And then after the earthquakes in 2010 in New Zealand, when the entire city of Christchurch came down, all along these rifts where literally farmers gained land and lost land. Some of those guys were milking when that earthquake happened, and cows got stuck on those platforms. Can you imagine? They had to come and take the roof off and get cranes in to lift up those dairy platforms. Crazy. All along those lines, we see milk thistle growing. I'm like, what is the milk thistle doing? What does milk thistle do for human health? Detox the liver. It's a detoxification plant. I'm like, what are you detoxifying? You know, you sit next to someone on the plane, and most of the time you're like, please don't talk to me, don't look at me. And I just got talking to this lady. Well, she happened to be a nuclear physicist, and what she said was, at the bottom, when Earth starts to move in these big ruptures of earthquakes, underneath is uranium. It releases radon gas, and it's coming up through the soil surface. Those plants are mopping up radon. So I looked at radon maps, and sure enough, all along the San Andreas fault line are these extreme radon levels. So ask the plant, what are you trying to do? Are you remediating this? Are you trying to deal with some kind of issue that's underneath the soil? Sometimes you might find these milk thistle, extreme detoxification plants, maybe where you've had a history of chemical use. It might be around the platform where you've been applying chemicals. We see these gnarly weeds. They might have spikes. They might have stingers, nettles, thistles. They're telling you to go away, and not very subtly, right? Go away, humans, stop it. Okay, so ask the question, what's the plant trying to do? Is that plant got a big taproot? Is it trying to open up the soil? If a plant's doing that, what is the mineral that will also be doing that? What opens up a soil, flocculates? Calcium. So generally what we find is these plants will be very high in calcium. Your dock, what you got? What else you got? Yeah, what about from thistles? You got lots of gnarly things you've sent around the world, by the way. We do thank you for your gifts. Like, I can read your landscape so well because it's in every country, except we call it Milan. Yeah. All right. But the common names might be different. But look, is that trying to crack that open? Is it covering the ground? Is it trying to protect soil carbon losses? So if you get scrambling plants, you're losing carbon. If you start to see a whole lot of bindweed showing up in your fields, if you've got plants that are like, oh, got to hold it together. We're losing soil, we're losing carbon. That's what those plants are trying to tell you. How can you address the issue? Japanese knotweed would be in that. Very bacterial also, low calcium. So disturbance events. These events might be natural or unnatural. It might be just the fact that you're going to be in there with livestock and it was wet. Have you noticed this at your neighbor's fields, that they were overgrazing when it was wet, and the following season it's a perfect square of yellow? Have you seen that? Doesn't happen at your place, right? Neighbor's place, right? They get this square of yellow, and it'll be cat's ear or dandelion responding to that loss. That soil is no longer breathing. You've got crusting on the surface. and up come these plants. It might be that your grandfather sprays DDT. Great disturbance. It could be waterlogging, fire. Do you guys get a lot of fire? Not yet. Okay, so New Zealand's having fires. It's amazing and not cool. But seeing fires in landscapes that have never burnt before. It's very interesting. So, what is causing the disturbance? Most of what we do on landscapes is disturb. Okay, so if you look at this as a disturbance succession, that we go from, this would have been a woodland environment. What would have happened here? How did this get opened up? What did we do? Burn it. Plow. Well, it's hard to plow a tree. Yeah, look, so we've got some trees. What are you going to do? Chop it down, burn it. You've seen those root rakes? Geez, that's something to watch. And they pull all those roots up out of the ground so they can get pasture in. All right, what have they done to take those trees out? These are all disturbance events. And we put on some urea, disturbance event. We put on some fungicides, some pesticides. They're all disturbance events. And what happens is, over time, we keep disturbing and we keep disturbing and we keep disturbing until we go to properties that are highly, highly bacterially dominated, and all will grow as early successional weeds, and herbicides will no longer work. We've made a system that's so bacterial, and it's disturbance, disturbance, disturbance. Okay? So how do we move the other way? Just stop disturbing it. Brilliant. Okay? So that could be rest. How are we going to move from the left to the right? Feed the fungi, yeah? So we might put some wood chips out, feed your fungi. We might use some compost extracts. We might get animal impact and recovery. Animal impact and recovery. When we're seeding, maybe we put something on the seeds, or we're going to drip and rip. If we're putting any mechanical, anytime you're dealing with iron in the ground, think, how do I feed my underground livestock? Is there something I can do to earn the right to cultivate or earn the right to rip? I'm going to put some foods down there so that I don't keep shifting my system to highly bacterial. One other way you can tell where are you on the spectrum is to get your refractometer and do a Brix reading. So if you don't know what a refractometer is, go and get one. They're very cheap. And do a Brix reading and look at who is photosynthesizing the highest, and whoever's the highest is winning the game of life, and it's telling you. So if you measure your thistles, and this is a good one for naughty kids, right? Get your children to measure the thistle. They like crush it up in the thing. And so take those thistles, take a look, and what you find is your annual grasses that you might be growing, or your perennial grasses might be running at really low Brix of 4 or 5, and those nettles are running at 12. They are winning the game of life. They are feeding their microbiology and their metabolites. So some of the effect that you see that you think is allelopathic and suppression of your crop due to weeds is actually because they've altered the biological community to suit them. And if you think about most of our commercial crops, so wheat and barley and oats, they are all weeds that we've harnessed and made more productive, but they actually like soils to be slightly bacterial. What we're finding is that we're getting more and more fungi in the system, active fungi, we're getting more nutrition and more yield. It is the highest determinant of yield is the amount of active fungi and biomass in your soil, not NPK. Your nitrogen and potassium will not work in soil systems that have a hugely fungal population. Has anyone seen that? That'd be your challenge. That'd be your challenge to see if I start to lift biological biomass and active fungi, what happens in terms of yield, right? It's the highest determinant of yield is fungal activity. Okay, so think about where am I on this succession. You might see in grazing systems, if your pasture sizes are too large and you're not getting adequate control, that what we see is those woody weeds start to encroach. In comes your blackberry, in comes your briars, and what happens over time is animals will ignore those areas and concentrate more heavily on others, so you have a mosaic of bacterial and fungal dominated in the same area. Have you seen that? See that encroachment, right? You can send away for soil tests, microbial tests, and take a look, and this is what you'll find, is those areas are now less disturbed, they become very fungal, okay? And then that's the germination signal for maybe shrubs. and maybe trees. And if you leave it and you keep grazing the same way, you're going to start to see shrubs encroaching. We'll start to see trees coming in the system. With me? Say, yes, ma'am. No, it's fine. You just whatever. Okay, so this example was just incredible to see. So Cotopaxi, Colorado. Yes, not your context, not your rainfall, not your soil type, not your environment at all, but the principles are the same. So Oswald Cattle Company, what you're looking at there is one of their highly diverse native meadows full of just all of these flowering plants, just phenomenal. This guy's doing a really good job with his grazing. And they have in this area what they call cheatgrass. So cheatgrass is an annual, fairly non-palatable grass. It's what's causing the fire cycles in grasslands in America. So very fire prone. I have one ranch that I work with, 370,000 acres, and they have burnt 10 times in the last 10 years. No, 8 times in the last 10 years. These guys are just on this fire cycle with this particular grass. All right, so these guys have had a field that they call the cheatgrass field. All that it grows is cheatgrass and purslane. Very low performance, very poor animal production in these areas. So what they did is they applied 25 pounds an acre, and I can say pounds an acre, can't I? You guys, kilos per acre, just to... Okay, you're good. All right, so of this high fungal compost, again, there are people here with Johnson Sioux down there, I believe. Is that right? You've seen it? Down there. They applied it as a liquid extract. They only sprayed it in 1 yard squared. Because the previous season, they'd actually put the extract out and they only got 3.5 inches of rainfall all season. Wow, wow. Right? Nothing worked, nothing grew. Right? Crops not going to really grow at that. Can you see where that went? It's literally a square of just where the extract went is where the cover crop grew. So they planted in that diverse cover crop into highly bacterial soils. They changed that to more balanced fungi and bacteria. Here's your cover crop. Here's your yield. Here's your growth. I just think doing trials like this can be so insightful and so powerful. Mostly, I think your soils are biologically like this, and when they applied the compost extract, nothing happened. Why did nothing happen? Yeah, it's already fungal rich. Not going to work. So take a look. If you're not seeing a result, ask the question, is this the appropriate input or stimulant for my land? Context is everything. So if you have highly bacterial soils and you're growing a bunch of weeds, try something like this. And do little trials like this. Like this was phenomenal to see. Can you see, or is it too dark? Yeah. I just think that's the coolest thing. It's nearly as cool as dung beetles, but not quite. Okay. So we can change that signal, set that plant up for success. And this is what the soil looked like when we dug in there. We're actually building carbon in front of their eyes. See that rhizosheath? I pulled that plant out, so I broke the roots, which wasn't very clever. But you can see that rhizosheath sticking to that plant. That's a sorghum Sudan. Very interesting. There was no cheatgrass growing inside those squares that was sprayed. That cheatgrass is not receiving the germination signal because it's too fungal. You with me? Good. All right. So we can see this in action. This pasture here was measured. It was 1-to-1 fungal to bacterial biomass. So we're talking about a handful of bacteria and a handful of fungi, 1-to-1. They came in and planted kale, chopped it up, cultivated, dropped that right back. Bacterial, perfect for kale. Harvest the kale, chopped it up, sent that to full bacterial biomass. So for every 2 handfuls of bacteria, you have 1 handful of fungi. Perfect conditions for, in this case, I think cat's ear. Do you call it cat's ear, or is it kazea? Sorry, you're lovely. I love you. That was brilliant. I'm going to use that forever. But you have these yellow, sort of taller flowering plants, right? Your buttercup loves these bacterial soils, okay? You guys look at what horses, it's not the horses creating these problems, it's your management, right? How are you impacting on that soil? Did we shift that bacterially, or have we created surface crusting? Those soils are not breathing, bacteria love it, your anaerobes are gonna love it, you're gonna get a different germination signal. Okay, so these guys tracked all this. So if we have, again, pasture sizes that are too large, you're not getting animal impact and not getting recovery, you're going to see this kind of stuff happen. You guys have bracken. Oh, thanks for gorse, by the way. Whose idea was that, right? Okay, gorse. Great. Okay, so we might, now gorse is interesting. So gorse and most clover legumes don't come under our succession, right? They're not a biological indicator. So some of your plant indicators are biological and some are mineral. Okay, so you've got to ask the question of what is it that this particular plant is doing. Okay, so some of them might be non-mycorrhizal. So these are plants that don't form a relationship with this fungus. So do we call it pigweed, red root pigweed, lamb's quarters? So Chenopodium family, Amaranthus family, Brassica, mustard, radish, shepherd's purse, Russian thistles. Oh yeah, you got Russian thistle? I've seen it. No? Lupins. Lupins! So even though they're a legume, they're non-mycorrhizal. They're one of, I don't know of any other legume that's non-mycorrhizal. So heather, is that non-mycorrhizal? Who's on heather? But it's non-mycorrhizal, right? I think so. Kosher you guys don't have, but sedges and rushes. So things that live in water, things that live as parasites, or things that have adapted for super low phosphorus or for areas excess in nutrients. So then they don't need mycorrhizae, okay? So mycorrhizae either help them overcome not having enough nutrients or to be able to deal with an excess. So think of your pigweed and lamb's quarters as being indicators of excess nutrient. Is that being fertilizer? Is that animal manures? Is it around the yards and trees? Where animals concentrate, do you see these kinds of plants? They're telling you mycorrhizae, your fungi are not working. Any questions about that? Yes, just yell it. Is it anything to do with alkaline and acidic? It could be, and that would be our mineral indicator plants, right? And so some of it we've been led to believe is because of the amount of calcium, magnesium, that these soils are more acidic or alkaline, but it might in fact be a biological issue. So blueberries need very, very, very fungal soils. Fungi make exudates that are acidic, and so people think I need to make the soil acidic with sulfur, but actually what you needed was fungi. What the blueberry needs is fungi. So ask in the succession, is where would blueberry be in this line? And blueberry is going to be up on the edge in the forest, right? So it's going to be fungal dominated. So if you are doing orcharding or viticulture, then it needs to be much more fungal dominated. Not the terroir of glyphosate, right? Because every time you do that, you're pushing your soil more bacterial, and then as a result, you're going to end up with virus. You're going to end up with root problems. You're going to end up with stressed vines. And it's a myth that we need stressed vines to create good wine. It's not true, right? It's not true. I know someone will shoot me. But it's like we can do this in good biological systems and make top quality wine. We don't need to be stressing them and keeping them in an artificial environment. Do you want to stress them slightly but make that fungal dominant? Did you want to add something? Yes. Yes. So what we're seeing, evolutionary, we're going to find them in like weedy species are going to be in slightly bacterial zones, but we're finding we're pushing our wheat more fungal and our perennial grasses even more fungal, and we're getting more yield. So some studies just out of New Mexico showed that 4 handfuls of fungi to 1 handful of bacteria were giving increased yields in wheat. But I don't know anyone that's doing that out in the field, right? That's greenhouse studies. But we're seeing that these are rules that we're finding we can push, and as we get more biodiversity and more fungal activity, we're seeing an increase in yield. Yeah, good question. Okay. So read your weeds. The other thing that you can do is a tissue test, plant tissue test. So test your weed and test your favored plant. So maybe as you're walking along, there might be some dock, there might be some nettles, there might be, oh, what's that one that's everywhere right now? Ragwort. Oh yeah, ragwort's a good one. So, no, the poisonous one, hemlock. All right, so you could, the lab's gonna love it. Send them a bunch of hemlock. Honestly, I send poisonous plants. They haven't complained yet. So send in your hemlock or your ragwort, and then send in right next to it if you've got some grass, your desired plant. What are you interested in? And look at where are they significantly different. We did a study on caraway. Did caraway come from here? I can blame you guys? No, it's Eurasian. Yeah. What? You do get it here, but I think it came from like India, maybe. Yeah, I think it's an Indo-Eurasian plant. Anyway, so caraway's come into the Americas, and grizzly bears love it. So what's happening is the grizzly bears dig up those roots late season, and then they're using that to put on weight so they can go to sleep and not eat people. It's a thing. Okay. Now what's happening is we're seeing increased human-bear interactions on these ranches because the caraway's coming up closer and closer to the house. So in fact, on this property, the 90-year-old grandmother came down and there was a grizzly bear in the kitchen with the fridge open. He's like, "Where's the beer, honey?" Anyway, so what we did is we tested the caraway and we looked for what is the caraway high in that's different, significantly different than what the grass is high in. And what we found is the caraway was significantly higher in calcium and boron. We tested the soil. Those soils where the caraway were much more bacterial. Areas where there wasn't any caraway growing, very high boron, very fungal dominated. The conditions are setting the scene for the health of this plant. So now that gives us a tool. Now, the first time I came across this was in 2000, and we had ragwort this high. And people would say, "Where do you live?" And I'm like, "We're the yellow farm, up Wrights Road." And everyone knew where we lived. The cows would lie down and you wouldn't be able to find them. So what we did is we tested that ragwort, and what the ragwort came back as was high in calcium, phosphorus, copper, and the soils themselves were low in organic matter and low in fungi. So what we did was we did an application of calcium, phosphorus, a little bit of copper, some vermicast, because everywhere I go I'm going to spread worm joy. Worm joy. And within 18 months, that ragwort's gone. And you can go back to that property, which we had 25 years ago. I'm so old. 25 years ago, and you can go back, and the only place you're going to find that ragwort is along the fence lines and in the gullies, right, where we didn't do any application. So I was like, well, this happens really fast. And then I moved to the Hawke's Bay from the Bay of Plenty, very different growing conditions, and that same effect took us about 4 years to achieve the same with other plant species. So what I want you to do is this. I want you to take a test. So here we've got ryegrass and capeweed. Do you have capeweed here? Not yet. All right, so South African daisy loves nitrates, loves nitrates, likes bare soil, likes a lot of lighter soil. So we find this on the east and west coast of America. We find it obviously in South Africa. New Zealand, Australia. Huge problem in Australia. So what we did, test the rye, test the capeweed. This is a leaf tissue test. These are very cheap tests. You can get them done at all your major laboratories, like ag labs can do this. And look where is it different. Nitrogen, about the same. Phosphorus, about the same. Same. Potassium. What do you think? Same. Good. Sulfur. Carbon. Calcium. No. Oh, what's happening here? It's like 4 times, 3.5 times the amount of calcium in that particular plant. We looked at magnesium. Magnesium was significantly higher. What's happening with sodium? 10 times the amount of sodium in that capeweed than there was in the ryegrass. Interesting. So, looked at copper. Copper was a little bit higher. Zinc was double. Boron, 10 times the amount of boron in this capeweed than what was in the ryegrass. And then twice the amount of nitrates, which we know. These weeds correlated with the soil test, which showed low calcium, sodium, zinc, boron, and high nitrates. So these are what we call the dynamic accumulators, right? Many of your deep tap-rooted plant species are dynamic accumulators. They bring up nutrients that are not so functional. So think of the ragwort. They're bringing nutrient that is low in the soil. They're making it functional, and they're actually releasing that through their roots. So there's plants that will take up an excess and then exude that nutrient into the roots, and they make those soils more nutrient bioavailable. Then they're dying down and they're adding that nutrient. So that's brilliant. So what you can do is you can go to Ibiza for 100 years on vacation, and these plants are going to heal your soil. Yay. Or you could say, I see what you're trying to do. I really appreciate your efforts. Thank you very much, and I'm going to do that for you. So in this case, we applied calcium with seawater, which I know is illegal, so just do it at night. You didn't hear it from me. There's always government spies. You got to watch. All right. A bit of boron, and we added some humic acid to mop up the nitrates. You could also add milk to mop up nitrates. Milk will convert nitrates to ammoniacal nitrogen in about 40 minutes. It's the coolest thing to see. So if you've got nitrate issues, which you do, by the way, right? It's in your waterways. You can see it all across these landscapes. A little bit of milk, go and try it, will convert nitrates, and you can test it in a nitrate test. Little bit of milk would be like 40 litres a hectare, which is 4 gallons an acre. Or do you talk litres? Just stick with it. Okay, we're going to go metric, people. Metric. Okay. So ask the weed, what are you trying to tell me? And then how can I do you out of a job? So this work was done in mesquite. I know you don't have this one, but pretty big issue in southern areas in the US. They did a nutritional foliar spray. Ask the mesquite, what are you trying to harvest? What are you trying to increase? And then they applied that as a foliar. Do I have the recipe? Yes. They applied it as a foliar, and within weeks, the bark on those trees split open. These trees are all dead. This is 3 years later after that application, and what was interesting is the grass flourished underneath. Right, so the grass came away, but those trees died. So she literally used nutrition. This is Betsy Ross, who unfortunately recently passed away, but she used nutrition to actually kill those plants, using like to get rid of like. What are you trying to tell me? Can I do you out of a job? So take a photo of this recipe if you want. I know you guys love recipes. Okay, so this is a chelation. You're making your own chelation. You're doing the suppliers out of a job. They're going to have to go and work somewhere else. They're going to have to find something else to do with their time. So we take 2.5 kilos of manganese sulfate. Now, this can be used to chelate your own trace elements. This is a way of you being able to apply trace elements, not thinking to kill stuff, but for nutrition, right? Those products need to be fairly fresh. You don't want old zinc sulfate. You don't want anything precipitating. This costs about $1 an acre. You can buy these products commercially for $50 an acre, right? You can make your own chelates. What you're going to do is you're going to mix this in with water. So 100 liters of water, and then we add that 450 grams of fulvic acid. It's a very slow brewing process. Think of like rolling. This water is rolling. It's not bubbling and agitating like your compost tea. We're just rolling, chelating, which means claw-like. We're going to hold on to those nutrients with a carbon source. Fulvic acid increases your cell wall permeability, just like it does with glyphosate. It'll increase how well. It increases it by 30%. So it increases access of foliar into the leaves or chemicals into the leaves by 30%. So you can drop your chemical rate by 30% by adding this bit of fulvic acid. Okay. Hello. Talk to you later, Roger. Right. Okay. So this might be something you want to take a look at. So take a look at what is your weed in particular high in, and would something like this actually help to overcome that hump? Am I missing some kind of trace elements? I suspect you might be. Yes? An alternative to seawater might be like a Celtic sea salt or an unwashed salt. And we could be using up to 100 kilos a hectare of an unwashed salt. We put the seawater on in Western Australia. I told them to do it at night, not tell the neighbors what we were doing, because that's crazy talk, right? You're in the areas that have the highest levels of salinity in their soils, about 50 million acres, and we're applying seawater. Going to get in What we find is that seawater is sea minerals, so a lot of these lands were very mineralized with sea minerals, and they have washed through the soils, and they might sit in alkaline areas or they've gone out to sea, but we find that these are critical missing elements. Sodium works like an electrolyte. It speeds up activity in the soil. Animals need sea minerals or salt, sodium chloride, so do humans, but so too does our underground livestock. All your microbiology need a little bit of sodium chloride. So if your animals, I find, like, can I call you a pom? It's all right. I find poms just, no? It's okay. It's not like really totally offensive, just mildly. Just I was talking about this morning, I had a pom wash, and my friend was like, what's that? My American friend had no idea what a pom wash was, but that's, you guys don't either, fine. That's what we call it in New Zealand, digging holes. Okay, let's move along. Is that you don't appreciate the value of sea minerals, right? Because we don't give as much sea minerals to livestock in this country, and the same in New Zealand, and we find animals really need it, right? And your soils will appreciate it. Do some trials, not telling you to do anything, but just try some different things. Yes, fine, sir. What's important, is the seawater or sea minerals? We're getting responses off both, but if I had to choose, I want to go out into lovely, clean Atlantic Sea. Are we near the Atlantic? And get some beautiful, clean oceanic water if you can, because there's also microbiology in that, right? There's living microbes in seawater that's different from the dried stuff, yeah. What about seaweed? And seaweed would be great, but what we're looking for is the sodium to work like an electrolyte. So the reason nitrogen does what nitrogen does is not because it's nitrogen, it's because it's an electrolyte. It gets systems excited. It's like giving a child a can of Coke and releasing them in a grocery store and then yelling at them for running around. Has anyone done that? Don't do that. Okay. So that's what nitrogen does, right? Gets the engine going. And that's why if you ever see a patch of urea that you've dropped on the ground, you're going to burn that grass. It's because you've had so much activity, you've burnt it out. So it's why people are scared of salt, is it's going to burn, like, because their engine's running so fast. But there's a lot of very lethargic soils out here and lethargic grass, right? So it actually increases the energy, the paramagnetism, the north to north poles in the soil. It's all about energy. Everything in soil is about energy, and that's why I like sea minerals. So I do use them a lot. Sweet. Okay, what we can also do is a weed extract tea. So it takes about 5 to 25 kilos of raw weed per hectare. You're going to harvest. I wouldn't do this with hemlock, right? I wouldn't do this with a contact poison, but you could do this with thistles or nettles. You're going to fill a drum. You're going to put a heavy lid on top. Don't add any water. And what we find it does is it concentrates those secondary metabolites. It concentrates minerals, and it concentrates and feeds the diseases that feed specifically on that plant. I don't believe that this works with a lot of grasses, right? So don't try this with ryegrass or your black grass, but try it with thistles, right? Well, no, because this is different from a comfrey extract. In terms of comfrey, we add water to it. We're actually concentrating minerals. We're trying to do a different thing. This is a herbicide. This works like a herbicide on some plants, if that's what this plant's an indicator for. So you need to try it. But the research says up to 25 kilos, so you're going to spot spray, because 25 kilos is quite a lot of material. So if you've got 10,000 acres, you're like dreaming, lady. Yes, I understand that. But we're going to dilute that and spot spray it. We've done this with thistles. It breeds up thistle rust. And you can spray it in lines, and you'll see this orange color of the rust where you sprayed. And that thistle's going to die. It's super fun. Especially for naughty children, right? They get to harvest the weed. Good question. So you're going to harvest these plants when they're in the active vegetative stage. So we're getting closer now with some of your thistles, like they're getting a little woodier. You kind of want to harvest them when they're really lush, but try it now, and you're going to squish it down until it looks like delicious Marmite. Right? It's got that sticky, it'll look like a sticky brown substance. Vegemite, what's your problem? Like, is there a choice? Vegemite? Sorry. Know your audience. Okay, so we're going to make that into that lovely sticky dark brown substance, and then you're going to dilute that 1 to 10, and you're going to spot spray it back on the same plant. Okay, so if that was nettles, spray it back onto nettles. Yes? You can do it with bindweed. What we found is it doesn't necessarily work on bindweed, but because it's concentrated in enzymes, everything else grows. So we see everything else boom, but the bindweed seems to like it too. So you got to figure out for specific. We've had great results with this with ragwort. We've had great results with thistles and nettles. So try other things. Tell me how you go. Send me your pictures. Right? Would it work with rushes? I don't know. We haven't tried it, but give it a go. I think rushes, because they're actually indicating a soil condition, that your soils are anaerobic and not breathing, then you're going to need to address that. So again, go back to those 5 reasons, interrelated reasons of why do I see this particular plant. Is this a dynamic accumulator? And rushes and thistles and rushes and reeds are not. Right? They might be high in silica. That might be something you'll get a growth response from, but these are activated by different conditions. Okay. Yes. I don't know. You're going to have to try this. Bracken might be hard to get into the mushy marmite stage. I'm guessing. Yeah. Yes. Yes.
When you're doing the natural farming thing of adding sugar and making the fermented plant juice, are you doing something similar?
So when we do the fermented plants and we're adding a little bit of sugar, yes, what you're breeding in that is enzyme. What you're brewing is enzymes. Okay, so we'll see a growth response. I'm using this as a herbicide. Okay, I'm using it as a herbicide. But again, you will see enzymes respond. So check it out. Play with it. Just have some fun. All right? And it doesn't have to, it could be just a bucket, but have a play. See how you go. Oh, this is the bindweed, right? So you can see where the bindweed extract was dumped. Just as a concentrate. She thought it had gone off, so the woman that did this didn't worry about it. But what you see is plant growth enzymes. Look at the line of where that was dropped. Drought on one side, non-drought on the other. It's the power of enzymes and these secondary metabolites. As we get plant growth, we get drought resilience. So maybe you could, so like I said, these commercial products, commercial ferments and commercial enzymes, and it's kind of what they're doing, right? They're just fermenting plants, plant extracts, aromatics, herbals. You can do all of this on your own place. You have all the plants that will heal your property on your own property. So start taking a look. Yes?
How specific about species do you have to be? I mean, if you, not using it to herbicide, you just, harvest 50 kilos, 100 kilos of almost random plants, push them down and apply them to useful effect?
So saying, should we harvest like a bunch of different plants? What we're trying to do here is because, like in this case, we're working as a herbicide. So we're really just like for like. I'm going to put like on like. So these things are like botanical ferments. That's a whole different topic, right? So yes, you can make botanical ferments. There's probably some good books. Land gardeners? You do that? Do you know any of their names? The books? Something. There are some books on doing this stuff, right? Okay, so have a play. Trial. We talk about setting up safe to fail trials. Okay, I had the guy had great results with ragwort, and then he freaked out because he worried that he might have put ryegrass in it and it might kill all his ryegrass. Right, it didn't happen, but he got scared, so he stopped making these. So try and, you're just harvesting that one plant. So you might have 4 drums with 4 different plants in it, yeah.
Why would you do spot treatments rather than remediating the whole field?
Oh, you could do a whole field if you wanted to. It's just you're going to need a lot of plant material.
But instead of looking before, as we were looking for the bioindicators of what potentially biologically or minerally could be wrong.
Yes.
It's just looking at it from a different perspective.
This is, so all of these things, you're going to leave this totally freaking confused. I promise. Because you'll be like, you were talking about biological indicators, mineral indicators, right? So these are plants generally that are our dynamic accumulators. And what we're finding is people are experimenting and finding this working with other plants. So my invitation is go and start to experiment and do some of these weed extracts, okay? And there is research behind it, but there's also crazy stuff happening in terms of we're breeding up disease organisms that are specific to that plant. We're breeding up enzymes that are stimulating all of the plants in that soil, okay? So just play, take, I hope you took good notes, that's what I say. Okay, so herbicides. Obviously working. We have over 512 unique cases of herbicide-resistant weeds globally. So since the advent of hardcore, well, even 1970s, you know, more applications of glyphosate, we've seen more and more species become herbicide-resistant. Weeds have evolved resistance to 23 of the 26 known herbicide sites of action. Do we need a bigger hammer? Yes, we do. We need to genetically engineer dicamba with 2,4-D. That's what we need to do. And then we can spray it, which they are doing. Anytime we try and outguess nature, nature wins. Have we wiped out any plants? Have we exterminated any of these weeds? It's quite funny working with the lovely Althorpe estate and looking at the amount of, it wasn't Tordon, was it not dicamba? Grazon. Thank you. The amount of grazon that's been applied in the last, since 1960, 30 years of grazon application, and the previous estate manager turned up who had been there before they started to spray, and he said, oh, it's so interesting. You've been spraying for 30 years. You still have the same amount of weeds, right? But now you don't have any legumes. You don't have any native flowering plants. You have no diversity for livestock. If you are feeding animals and they don't have any forbs in their diet, they did a study in New Zealand on ryegrass and clover. Those animals' cortisol levels are through the roof. You are stressing your animals out. It's an animal humane issue. You need diversity in those swards. They also measured their purpose, which I haven't figured out how you measure a cow's purpose, and apparently they had no purpose. They might be measuring like depression or something. I don't know. So animals need purpose. They need to be foraging. Okay, so we don't need a bigger hammer. It's not, weed resistance is not due to a deficiency of herbicide. Okay, it's a biological or nutritional issue. Glyphosate-resistant plants have evolved resistance through an overexpression of the shikimate pathway. So you're all familiar with the shikimate pathway? All right, so it's so if we go back to our gene expression, what happens is these plants, so the action of the herbicide works on the shikimate pathway. These plants have gene expression. They overexpress on that pathway so that the pathway doesn't get shut down by the herbicide. Does that make sense? So we overexpress on that. What's fascinating is you can switch off that gene expression with aromatic amino acids. We can switch it off with the application of putting fish in with your herbicides, or our worm extracts or fulvic acid are switching off this gene expression. So I want to show an example of this in action. So Di and Ian Haggerty, you've got 55,000 acres of sheep and cropping, 8 inches average rainfall. They got it easy. They're in Western Australia. You walk around there, right, and the flies, and they get between your sunglasses and your eyeball and they bounce. And I'm like, they still have PTS from being in Western Australia and the flies, right? It's a thing. What they do is, after they graze their sheep, they drill their seed with a worm extract at 5 liters per hectare. Okay, so they're putting a worm extract on with an auger directly on the seed. In the season, they're spraying 120 liters of compost per hectare. That is their only inputs, apart from a low rate of glyphosate early season. Everything's that's it, right? That's their entire program. No NPK, and they have been doing this for decades, right? Now, what was really interesting is some of these properties that they were taking on newly were again in the same situation of requiring 5 to 6 herbicides to control their weeds. And what was interesting is when they brought these properties, you go into these sheds, and these guys are using banned herbicides. Like, they have everything in their shelves because they can no longer control their weed pressure. So what was interesting is, so in the first year of taking on new land, what they find is they grow button grass, early successional bacterial-dominated grasses. They grow kerosene grass. Does that sound like a good idea in Western Australia? Windmill grass, it's also known as crack grass, because get this, it climbs up the back of your pants and out your crack. And it literally does that. It's this little windmill thing that creeps up your pants. It's so uncomfortable. Anyway, so that's what they notice year one. So this, during summer, after they harvest their crop, in come those early successional weeds, year one. Year two, this plant arrived called Ceteria, or it's one of the Ceteria species. It's a native C4 palatable grass. Look where it's growing. This showed up. They had a little shower of rain, and this showed up on thousands and thousands of acres. This plant that had not been seen in the district for 60 years looks like someone's sowing it. What's happening? It's getting the signal to germinate. It's a biological signal for these native grasses to germinate. They now have forage for their sheep during summer, right? Otherwise, it's very, very poor forage out there, right? Super low rainfall. You're not allowed to say sandy soils. They're silver loams or red loams, but actually it's sand. But I try not to say that in front of them because it hurts their feelings. But sand, okay? So interesting. So this is their program. So 5 liters worm extract down the drill, 120 as a foliar in the growing season. So what they did was they sent away soil. And they sent away soil from inside where they'd been doing their treatments, cups of soil, and they sent a couple of cups of soil from areas that hadn't been sown, right? So it's still on their property, but hadn't had any treatment. So Prospect is the name of the property. So what they found was the seed that had received these treatments of worm liquid, those herbicide-resistant plants, so rye and radish, were being killed at half the normal rate of glyphosate and half the normal rate of trifurulin. If they were outside these areas that hadn't received any treatment, it was taking 5 applications for them to control those weeds. How cool is that? This is huge, right? This is one of the biggest issues we're facing around the world right now is herbicide resistance in cropping, looking for bigger hammers, instead of asking the question of what is the microbiology doing and what is the signal. So we did a presentation at the big grain research conference, me and Di and Ian, and we said, you guys need to come and look at what's happening here because we don't understand it. So we said, the door's open, come and take a look. We were flocked by millions of researchers. You wouldn't believe it. Not a single researcher has gone to have a look at what's happening here. And so you want to get interested in this. This is like knee capping, whatever. Taking people off at the knees in terms of being able to produce food because of herbicide resistance. And these guys have solved it just by stimulating microbiology and dropping their rates, putting a worm extract down. It's a very good quality worm extract, but this is a biological signal. It's switching off the gene expression in the shikimate pathway. I don't know actually what trifurulin works on. Does anyone know? What's its mode of action? Yeah. I think it's probably banned here, but they're using it. Okay. Very good. So thinking about how we're going to transition, how we do that profitably, we need to repair and regenerate this microbial bridge. And we need to build our observation skills. So what are we doing to enhance diversity? What are we doing to support optimal microbial activity and biomass? Who's driving all of that? Who's driving the secondary metabolites and the biological diversity? Who's doing that? The plant, right? It's that plant microbial interface. The plant stimulating the microbes are stimulating the plants. Back and forth it goes. These things are not in isolation. So supporting optimal plant nutrition, diversity, to stimulate and build that microbial biomass under the ground. Here's our secondary metabolites. Here's our flavonoids. It's freaky once you start working on some of these programs. In arable is where we see clean beds. When those plants start to germinate, they're changing the signal into row, and we don't see inter-row weeds. It looks freaky when you first start because these beds are clean. And you're like, I wonder, it's an odd experience with no post-emergent herbicide. Right? Okay, we got time for some questions. Don't keep asking me about the extract. Go and play with it. It's in my book. Yeah.
I have a question about how you measure the fungal population versus the bacterial population in the soil.
So how do we measure the fungal bacterial populations? There's labs here, is there not? Yep, so we have PLFA testing, we have counts in terms of soil food web testing. Those labs are in this country. Yep, so take a look. Yeah.
We feed Himalayan rock salt to our stock, but should we be concentrating on a sea salt option rather than Himalayan?
What does Himalayan rock salt not have in it? Iodine. So we really want a Celtic rock salt. It's got more diversity. So I think it's got like 90 trace elements in your Celtic rock salt here. That Himalayan has 70. And the one that it's missing that's important is iodine. So I wouldn't even have it on the table at home for your own food. Not getting enough iodine in your diet as it is, unless you're eating seaweed. Try brown rock salt. I don't know what your brown rock salt's got in it, but it's just cheaper. Yeah, I mean, cheaper doesn't always mean it's not good, but ask for a mineral breakdown.
Do you have any thoughts about how any of these processes could be adapted to increase resilience against climate change?
Well, I think this is all about resilience against climate change, right? Your microbes are like 90% water. We build that biomass, you've got water exchange happening. We want to deepen the roots, build your mycorrhizal relationships. I do believe that climate change is due to land management and the water cycle more than carbon. I'm sorry, carbon markets, wah, wah, right? So, I mean, I think getting in behind land management, thinking about the role of microbiology in cloud seeding, thinking about how water works in your catchments here, we really need to be building resilience by looking at it as a land system. And, you know, carbon, nitrogen follows carbon, water follows carbon, but one of the biggest things that I think is really interesting that people aren't aware of is when fungi take carbon, hydrogen, and oxygen, and they take that from leaf litter or from the plant, they take some of that carbon to form chitin in their bodies, they take some of that H and some of that O, they make water. So fungi are actually hydrating these landscapes. So get fungi in your system, they are your backup when it gets dry.
Great presentation, thank you.
You're welcome.
I was riding in Richmond Park on Sunday, and in the last 5 years there's been a huge take-up of bracken fern under all the trees, just masses in the last 5 years. Very short on livestock density and big on tourist density. What do you think needs to solve that problem?
I won't say anything rude. Yeah, it's off the record. No, so look to that bracken. You'll find often they're very high in iron and silica as well, I think. But yeah, we need more. Use the tourist. Can we put the sign fence this way and get them trampling it? That would be great. I mean, we have used things like molasses. So those soils under the bracken are asleep. They're what we call the sleepy soils. How can we wake them up? Maybe a little bit of molasses. When I say a little bit, I mean like 1 litre per hectare. Small amounts just to kind of wake up that soil. But yeah, I'd use the tourists. Get them working on it. But yeah, we do see bracken encroachment. We need livestock. You need a livestock impact. Put a salt block in the middle of it. Put your hay in the middle of it. You're worried about them damaging and trampling ground over there. We'll put them on the bracken. Ooh. Yeah, yes.
When we go out and buy a new strain of seed to plant our crop, how do we match the ground that seed was trialled in so that we know which piece of our land to put it in, whether it's a high back or high fungi soil?
So you don't need to worry about matching it. The plant's going to do it. What you're going to do, though, ideally, is you're going to put a seed dressing on it. And I want a seed dressing of a high fungal compost or a vermicast or a little bit of seaweed or something on that seed, so that when it germinates, the minute it starts germinating, it's signaling to the biology it needs for optimal health. So you don't have to guess what was this plant growing in or what does this plant need. The plant's going to do it itself. But by having a biodiverse compost or something, you're taking the guesswork out. It's a good question. Right. Yeah.
Yeah, on your amazing course the last couple of days, you're talking a lot about the problems with when you use hard water for making the extracts. A lot of us might be in the position where we only have that water, so mains water, and even so, you're also saying like water coming out of the sky might have tons of other stuff in it. I mean, to what extent should we get really kind of worried about the water we're using?
I try not to worry about anything because I find worrying is praying for what you don't want. That's what my mother says. So I think more around if you're collecting rainwater using those humics or fulvic acids when we're using that material. You can filter through a humate to soften your water. You can use a lot of commercial water softeners. You guys, some of you have a hard water problem. Biologicals will not work if your hardness is over 160 parts per million. The biologicals just don't work. So if you have super hard water, then take a look. Do I need to soften it? Because water might be your main problem. So yeah, check it out.
Talking about resistance, we've got incredibly resistant ryegrasses which grow in cereals. So I understand, improving the fungal populations in our soils to outcompete the nitric type weeds. Yeah. But when we've got weeds that are similar sort of successional stages, like ryegrasses and wheats and barleys, what would your thoughts be on how we can overcome that kind of conundrum?
So it's still the same thing in terms of that overexpression in the pathway that the herbicide's working in. So what we're finding is we're switching that gene expression off with the use of these worm liquids and the composts and the fish. So those types of things are altering the gene expression in the ryegrass. So that graph that you saw before was actually in ryegrass, right? So seeing that effect is because we've altered the gene expression, we've altered the biological community. Some of this we're guessing because we're looking into the literature, and some of it we have no idea there's something going on, but no one's helping us to work out what's happening here. But I see it on properties again and again. I've had cropping guys who are standing out in an arable field and we're like, oh, it's a really good year for wild oat. We've got no wild oat. And I go, well, the bloody neighbor does. Right? So we're changing that signal in the soil so we don't see wild oat, we don't see ryegrass, we don't see radish, because we're changing the signal of who germinates. Your fingerprints, your sticky little fingers are all over the landscape, and they're telling you who are you signaling for. Are you signaling for these weeds, or are you signaling for optimal health and nutrition? So look at what have I been doing management-wise that's enabling these plants to flourish. But it'll be good work. I mean, if you want to do some trials, I think that would be great. Yeah. Right.
If we haven't got vermicast or compost to make extract, is it worth buying things out of a bottle that people are trying to sell us that are good bugs to put on your land?
It could be, and I think unfortunately this is the piece of us figuring this out, and that's where that little trial, the 1 square yard by 1 square yard, and just take a look. What's lifting my plant photosynthesis the highest, just in case you are being sold any snake oil. It's not hard to make good quality compost. You don't need a lot. Go and watch videos on Johnson Sioux and you can make some beautiful compost yourself. There are people in this room and out there that are actually doing really good products. Always ask anyone that's making compost or vermicast, I want to see their biological test. Have you got nematodes? Have you got protozoa, and are they at good high numbers? And if not, and fungi, I'm not going to buy it, right? So most compost and vermicast, don't buy municipal waste. Yeah, duh. Right? That stuff is not being made for agriculture, and agriculture's always been the dumping ground of the urban waste. We don't want their waste. We want good quality. So it won't be made by a company that's doing municipal waste as a general rule.
Give free choice minerals to the animals, to livestock.
Yeah.
Help only the animal to balance, or if you concentrate the management and concentrate all the manure, help to increase the minerals in the soil too. With the manure.
Is that what you're testing and you're finding?
I'm trying, but
I very rarely find people lift their soil minerals through trace element through free choice minerals. The only time we've seen people really lift their minerals is through the use of like zinc oxide when they're treating disease. That's about the only time we've really seen levels go up. If your animals are doing that free choice, they need that mineral. They're going to use it in their body. Yeah. So.
Yeah. Hi, Nicole. Thanks very much for your talk. Why do you think the government haven't made the association between soil biome and human biome? Why do they not get it? Because it seems, when you talk, so obvious.
I think so, but I know that's a question for your politicians, right? I mean, politicians are busy doing politician things. You know, are they connecting this? I'm finding even the academic world's not connecting this. And I think it's part of just being in silos in our own thinking and in silos in our industries, and it's part of a systems change, right? Is that you want more people like me that are generalists, right? You want people that are not just in a silo, that are seeing the systems and the patterns and the interrelationships. So I think the question is more, how do we get more of these people, and then how do we help educate those guys? Because right now we're just working in a system of reaction, and we need proactiveness and thoughtfulness and people that can think. So vote for people that think, not that like allowed.
Hi Nicole, thank you for both Althorpe and here. You talked a lot about biologicals, but what about soil chemistry, and how important is it to get that right, either before or during the addition of biologicals?
It's interesting because you got to figure out, is my imbalance of minerals what's putting a drag on my system? And then it might be something you have to overcome. But what we find is biology can do some crazy things with minerals that we can't expect. So we did a biological application, just biostimulant, so fish, seawater, and sulfur onto high country stations with an aircraft in New Zealand, mainly sheep. And our base saturation calcium, so the amount of calcium in your soil, which was very low in these properties, I think it was about 36%, so about half of what many of you have, within the year had lifted by 10% across 5 different sites. So it had gone from 36 to 46, no application of calcium. And there was all the activity of microbiology and macrobiology like worms. Right? So sometimes I think there's people that come in and say, you need your numbers and your ratios to be perfect. You're going to spend a fortune doing that, and it doesn't necessarily change your outcomes. So what I'm more interested in is, how do I support the plant for optimal health so the plant dictates the minerals? Because right now what we find is you have very shallow rooting systems, you don't have a rhizome sheath, you've got naked white roots, you're basically farming hydroponically. Because those plants have no defense, they don't have a gut. They have leaky gut, really. Right? So there's no interface between them and what's happening in the soil minerals. So unless you've got a super high magnesium and you're cropping, then maybe I might like put something down just to help address that again, just around the root system. But I'm not going to go and put tons and tons of stuff on. There's a lot of evidence out of Australia on this too, where they do like 10 tons of lime and your pH goes up and then it drops, and they do 10 tons of lime the next year, and they don't get any response until they put biology on. So you got to see, like, is it a biological problem? Is it a mineral problem? And you really need to do these diagnostics. And that's part of why we're bringing Create here, is that I can train people to do this work, because I got to like plant some seeds in my ground right now and it's not doing very well. All right. Thanks, everybody. Oh my gosh, it's been so much fun. You guys have been amazing. Thank you.